All right, good morning, everyone. Welcome to the second day of Neuro Academy. We are very fortunate to have Russ back on deck to talk about a different topic than yesterday. This is something last year, Russ, when we invited him and when he joined us last year, he proposed to talk about something that he had started being interested in, which is AI-assisted programming. This is probably something we're all thinking about in one way or another, and it's just really appropriate for this event, for this audience. And Russ was so kind as to agree to talk about this again, and I'm interested to hear a year in AI terms. A year is like a decade in any other sense, so I'm very curious to hear how his thinking has evolved since last year on this, and I'm sure this will be very useful for all of you as you're thinking about programming, which is the next thing we'll do after that, which would be learn more about programming. So Russ, take it away.
All right. As yesterday, feel free to stop me, at any point. If you have questions, just raise your hand. Yeah, so I, just give a little bit of background. I've been doing kind of workshops on clean coding and, coding, reproducible coding practices. And then, about a year and a half ago, when suddenly the AI tools became really prominent for coding, and I've been using some of them for a while, but when GPT-4 came along and there was this, kind of leap in performance, I became really interested in I'm spending all this time teaching people how to code. Do I even need to do that anymore? Or is everybody just going to be using AI to do everything? And so I started looking. Ended up doing some actual, not kind of quasi-empirical work on, and I'll show some of the results today on, how these tools actually work. And then I'll kind of say a bunch of things about kind of, where I see them fitting into workflows. Rarely have I had a talk that I wrote and then a year later it felt like it needed to be heavily revised because things had changed so much. And so it is, as Ariel said, it's a really fast moving area, but I think I think we've learned some useful insights. So just as a show of hands, how many people have used AI to help with coding? Okay, pretty much everybody, as I expected. So what are the punchlines today? Clearly, these tools are very powerful, and if you're not using them, you're probably wasting time, and also, probably misspending your time. But they raised a lot of really interesting questions about, how do we teach people to code? How do we, how should we think about reproducibility? Those types of questions. I'm not going to go into any detail about the models that underlie these things, but it's really the large language models like GPT-4 and others that have kind of underlied the ability of these tools to perform so well. And it's also the availability of tons of code, particularly on GitHub, where one can go and, well, if you have access to, Microsoft's databases, you can get, probably billions of lines of Python code. The first AI coding tool was from OpenAI. It was called Codex. It was basically a version of GPT-3 that they trained on 150 gigabytes of Python code from about 54 million public GitHub repositories. And they basically found some analyses of this, found that it could program about as well as better than most first-year programming students on code writing questions. This was deprecated in 2023 in favor of the GPT-3.5. It turned out that training these models on code actually made them better at doing stuff that wasn't code. It almost taught them how to think a little bit, which is really interesting. This is an example of the tool that I use the most, GitHub Copilot. I'm just going to play a little video of me. Basically, this is kind of sped up, but oh, I'm sorry, you can't really see this. But I put a comment at the very top, try to run each file in the code directory. And then all I'm doing is just tab completing. It's suggesting code, and I'm just hitting OK. So all of the code that has popped up here has been written by well, now it's GPT-4. Basically, based on that one prompt. And in this case, I think it pretty much got it right. Sometimes it does, sometimes it doesn't. GPT-4 came out a little over a year ago, and it was tested on problems there are these code platforms where you go to like do problems and, show how good you are at coding, like LeetCode. And so they, one of the things you have to be sure about when you're testing a model is whether it was trained on the problems that you're testing it on. That's that leakage problem that I talked about yesterday. Here, they could be sure that these LeetCode problems weren't in its training diet, as we call it, because these were problems that had been posted after the training of GPT-4 had finished. Now GPT-4 is being kind of more constantly trained, and so it's harder to do this. But in these initial tests, it performed much better than the earlier models, and it performed on par with human coders from LeetCode. And these aren't necessarily like, elite coders, but some of them are, some of them aren't, sort of a range of coding skills there. But certainly it would seem to be, roughly as good as like, the average programmer, at least. Since then, progress has been, sort of steady, but pretty incremental. The leap from, this was the leap from Codex to GPT-4 was sort of somewhere right up here. And then there's all these other models that are kind of adaptations of GPT-4 with additions for different types of reasoning and things like that. One of the problems is that like this is this human eval benchmark, which is 164 problems. And you can see that we're basically hitting asymptote on the benchmark. The latest models are basically at 100%. So you can't, so we need better benchmarks. And there are better benchmarks. There are harder ones than this. Where these models are not doing well. Another thing to note is, back when we started doing this, there were no open source AI models that were very good at programming. Now, the best open source models that you can like get and run on your computer if you have a GPU are basically about as good as GPT-4 and are actually much smaller than GPT-4. So, we're seeing good progress on the development of tools that are more openly available and accessible. So I think you can make the argument that coding is an optimal use case for large language models. And one of the problems with language models is they sometimes do what people call hallucinate. They make stuff up. And this was a really fun example that we were playing around in my lab about a year ago. And this was with GPT 3.5. We came up with this example. So we asked it, who's Wayne Poldrack? And it says, Wayne Poldrack is a prominent neuroscientist known for his work in the field of cognitive neuroscience, blah, blah, blah. Currently a professor of psychology at the University of Texas, Austin. Wayne Poldrack is my dad. He's a retired accountant who lives in Rosenberg, Texas. He's not a neuroscientist. And so it gets better. If you ask him, what awards has Wayne Poldrack won? It tells you that he's won a bunch of awards, a couple of which are awards that I won, most of which are awards that I have not won. Some of them are awards that don't even seem to exist. This is the best one, if you say, is Russell Poldrack a different person? I believe you may have meant to ask about Russell Poldrack. It tells you that they misspelled my name because my grad student, Lindy, wrote this. Russell's actually the same person as Wayne Poldrack. Russell's his middle name, and he often goes by Wayne rather than Russell. So GPT 3.5 thinks that my father and I are the same person. So why is coding like an optimal use case? Well, coding is great because we can write tests. We know how to make sure that I think large language models are great when the bottleneck is in generation, but verification of testing is relatively easy. And this is a case where that's definitely true. So we'll kind of look at that as we go on. So I'm going to tell you about some experiments that I did. These were done a little over a year ago with a slightly earlier version. So the new GPT-4o now is multimodal. So you can, as I'll show you an example, you can give it images and it can handle that. And interestingly, people reported that GPT-4 got worse in mid-2023 because of some tuning that, they're always tuning to try to make the model, not behave badly. And some of that tuning seems to have actually made GPT-4 worse. I didn't go back and redo my experiments after that. So I don't know how this relates to the current performance of GPT-4. My guess is it's roughly on par. Maybe the model might have gotten a little bit better, but I think it's probably incremental. So here's the first thing I did. And this was, like I said, these are kind of quasi experiments. They're fairly qualitative, but I think they're useful. So I gave it 32 coding problems. This was done just using the ChatGPT interface. And they were just problems that I made up, and I'll show you some examples, focused on data science, statistics, machine learning, and text mining. This was done when I didn't really know what I was doing in terms of, writing prompts. We've learned, I think the biggest thing that we've learned in, in this area is how important it is the way that you design the prompts, what we call prompt engineering. And I didn't really know what I was doing then. So it almost certainly the models could have done better with better prompts. And the assessment's completely subjective and qualitative, as you'll see. So what I did was I had it give me solutions to each of these problems, and then I tried to run them. And then I basically try to work with ChatGPT to get it to fix the problem. And I'll show you examples. And I basically, at some point, I gave up after roughly 5 minutes. And so this is showing how many prompts it took me to get the ChatGPT to give me what I considered a successful solution. About a third of the time it gave me something that worked on the first prompt. About another third of the time it took, additional prompts up to 8. And then about a third of the time, quarter to a third of the time, it basically was not successful in what I mean by that is I didn't want to spend half a day trying to get it to solve the problem. So I gave up after a few minutes. So that's basically about a quarter to a third of the time it kind of didn't solve the problem. Here's an example of one that it got on the first shot. Create a simulation in Python to do the following: generate some synthetic data, fit 3 models to the data, a linear model, a second order polynomial, and a ninth order polynomial. Compute the error for these models on the training data and on a synthetic test data set, and plot the fitted lines for each of the models overlaid on the training data. And so it writes some code for us. Looks like pretty clean, nice code. It puts in a few comments saying what it's doing. Code's pretty readable. And this is the plot that it gives me, which is basically pretty much exactly the plot that I was looking for. Some of you might know what this plot is getting at. There's a point that this plot is often used to exemplify. If you pick up an older machine learning book, you will see a version of that plot. So let's see, so I didn't mention anything about what that plot is meant to be about. But GPT-4 seems to be pretty good at actually telling you what code is trying to do. So I said, what concept is this simulation meant to exemplify? It's meant to exemplify the concept of overfitting in the context of these models. Of course, when the model becomes too complex and performs well in the training data, poorly in the unseen data. That's exactly the point that I wanted to make with that figure. And so it kind of understands in quote, what's going on. Here's another example of, its ability to explain what code is doing. So I say, please generate a large number of samples from each of several distributions and compute the mean of each sample, then present histograms of each of these sample means. So it does that. This is what it looks like. It took me a bit of tweaking to get it to show me that thing. And then I ask it, what is this meant to illustrate and how? It's meant to illustrate the central limit theorem. States the distribution of sample means a sufficiently large number of blah, blah, blah. So if a student in my intro stats class could explain this, I would be really happy. It goes on to actually go well beyond where I would have expected students in my, pre-calculus first order stats class to go. It's important to know that the Cauchy distribution is an exception, as it doesn't have a finite variance. I put it in there for that reason, right? So basically central limit theorem doesn't work for it, right? I would be really happy if a student could explain the central limit theorem to me and, in that class in this level of detail. Okay, so let's look at what happened when it went wrong and I had to work with it. So I mentioned that, about a third of the time I needed additional prompting, and there various things happened, right? Sometimes it tried to use outdated package features. So it tried to use a version of scikit-learn from 2020 or 2021 that was now, these packages often move quickly, and so that feature didn't work anymore. Sometime it got confused about types. It tried to work with something that was a list as if it were a dictionary. it sometimes hallucinated non-existent packages. So if you tell it to do something, you know, to solve some problem, it would often make up, or occasionally make up, a package name that like is the thing you're trying to do that doesn't actually exist. There's apparently, it's now been seen that what people will do on occasion is find cases where the large language models do that, and then go put on the Python package index a piece of malware that has that name, so that then if you import that package, you're actually importing malware onto your system. So you have to be careful about like what packages it's actually calling in. And sometimes it would just do the wrong thing with particular data. So here's an example. This is actually a good one. So I asked it to generate a Python class that fits a hurdle regression model, which is a particular type of regression for data that are zero inflated. We have a bunch of zeros, and then it's basically counts. It's meant to model counts where there's a lot of zeros with a scikit-learn type interface. And so it tells me something about what a hurdle regression model is. It kind of gets it right. And then it says, below is a simple implementation of hurdle regression. And it starts out by giving me a linear regression model for the part that's supposed to be modeling counts. It's not the regression. So I say the continuous model should be a regression method that, and it doesn't care about misspellings, that is appropriate for counts. You're right. It often says you're right. For count data, it's more appropriate to use something like Poisson. So it's going to use a Poisson regressor. Then now I run it and it says, oh, there's an error. The solver needs samples of at least 2 classes of data. The data only contains 1 class. And the problem is that the data set didn't include any zeros. This method requires that there be some zeros in the data set. So it says, oh, sorry, let's use a different data set that we know has zeros. We're going to predict the number of rings on an abalone. Okay, so that works. And now what I want to do, hurdle regression, there's no like real implementation of it that I could find for Python. There is one for R in this package called PSCL. And so I said, please create R code to compare these results to an existing implementation of hurdle regression. And it says, okay, here's some R. We'll use the PSCL package, some R to do the thing. And the models look pretty different. Okay, so in terms of the result, the mean square for the Python model was 7.75. Same data mean square for the hurdle method was 108. So clearly they're fitting the data differently. I had to do some debugging by hand, and I got them to be pretty close, 5.19, 5.04. But looking at the model itself, the way that it fit the model, it turned out that it fit it incorrectly. That what you're supposed to do is basically combine the likelihoods of the 2 parts of the model and then maximize that likelihood. But what it did instead was it separately fit the count model and the binary model to the data and then combined the predictions, which gets you close, but it's actually, depending on the data, is not the right solution. But what's interesting is if you go look at, there are like, you know, repositories on GitHub that implement this in Python. All the ones that I could find implement hurdle regression incorrectly. So GPT-4 learned how to do it wrong from GitHub, and now it's doing it wrong, you know, successfully, but incorrectly. So you have to worry about the wisdom of the crowds on GitHub. Okay, so it also failed on occasion. And one time there was like a required library that wouldn't run on my system, and I didn't want to fight with getting that library to work. The rest of the time, it couldn't solve the problem. Here's an example. I wanted it to generate code to implement this thing called the easy diffusion model. This is a model that people use for reaction times. Diffusion models are models that are meant to understand kind of the underlying features of response times, like how cautious you are, how quickly you accumulate information, and so on. And this is a closed form version of that. This is the details of the equation don't really matter. This is the equation from the paper, the Wagmacher's 2007. So I said, you know, generate Python code to simulate that model, simulate 1,000 trials, and estimate these parameters using the easy diffusion model. Okay, so it says, tells me a little bit about drift diffusion model. It gives me some code. And the first thing I see is it has this line, minimize this stuff. And if you're using easy diffusion, you don't need to minimize anything. You just need to do a computation because it's a closed form solution. So I told it, oh, it uses closed form solutions, doesn't require any optimization. I'm sorry. You're correct that it provides closed form. Here's the corrected Python code. This is the code that it wrote to implement it. This is the correct equation. And that's if you take its code and write it out as an equation, the thing on the right is the equation that it created. And what's interesting is that like there's a few parts that it kind of gets right. And particularly it gets this like power of 1/4 at the end. But then the stuff on the inside is just totally wrong. And in general, people find often that GPT-4 has a lot of trouble with math. So what about, so now I said multimodal GPT-4, like you can give it images and it can do things with them. So I said, can you tell me the equation for the mean drift rate denoted as V in the paper? And the formula for the mean drift rate V is here, is what they give me, which doesn't really match it kind of matches how GPT-4 said to implement it in its code. Doesn't match the reality at all. And so I said that equation is incorrect. Do you have access to the original paper? Could you look at the image from equation 7? And it says, sorry, I can't access it. And I said, okay, here's an image of the equation. Thank you for providing the image. Here's the equation. And you can see it just does it. It's again, not that far off, but it misses enough that it just wouldn't get it right. So the multimodal stuff gets closer, but it's still, when it comes to math, it's not particularly good. I'll show you another example where the multimodal stuff actually works pretty well. Okay, so it's often successful at generating code. One problem is that it doesn't give you a confidence signal. There are ways to get confidence signals from these models, but they aren't exposed here. So you don't know whether it's like just guessing or whether it's very confident in the answer. It kind of like is presented to you the same way each time. And so they say this in the tech report, right, that care should be taken, particularly in contexts where reliability is important. Science is an area where I think reliability is important. Okay, I'm going to skip over some of the other experiments we did about kind of code quality, which show that actually it can do a decent job of actually fixing code, making code look better. Now I want to see, can it actually generate tests for its own code? We think testing is important. Can it generate tests? So I now use GPT-4 to generate some coding problems that I then gave to GPT-4 to solve. So I start by saying, please generate 20 problems to ask a chatbot to create Python code to solve a variety of physics problems. And I did this in various areas of science. Here's an example of what it looked like. Create a Python function to model the population growth of a species using the logistic growth equation, given these parameters. All the stuff that's italicized is stuff that I had to add just to give me output that I could kind of programmatically work with. I was doing all this in general. Now, if you're going to do these kind of experiments, you would do them by submitting these things via what's called the API, the application programming interface, where you can automatically send this stuff in, get results back, and then process them without having to do anything by hand. And so that's why I had to generate all this stuff. So importantly, I said, generate a set of PyTest tests that exercise each of the functions embedded in a separate code block. So it gave me back tests and code for each prompt. It never said, sorry, I can't do that. And 97% of the code worked without errors, without crashing is what I mean. And it actually did a pretty good job. So you can compute how much of the code is actually exercised by the test, like how many lines in the code are being tested. That's what we call coverage. And more than half the test had 100% line coverage. I meant that every line that could be run in the function, these are pretty small functions, but every line that could be run was being run by the test. So if there was something wrong with it, we should, in theory, be able to find it. So PyTest is the framework that we use. I think Ariel posted yesterday the link to my PyTest tutorial if you want to learn more about that. So all of the tests passed for almost half of the problems. For just over half, for 54 out of 100, at least one of the tests failed, which means basically the test ran and it said, sorry, this test did not pass. And usually that was because the test was asserting that something should be true. Remember, I talked about assertions yesterday. And that assertion, like, you'll see an example, that assertion turned out not to be true. Sometimes the test said, if certain thing happens, you need to raise an error, right? Like if I'm expecting an integer and you give me a letter string, then you should not just process it, but you should actually raise an error. And 11 out of those 100 times it failed to raise an error. So here's a fun example. One of the tests was to compute the escape velocity of a planet, given its mass and radius. And that's this function that it wrote, escape velocity. So the test basically said, okay, let's make sure that it gets it right for Jupiter. We know the mass and radius of Jupiter, compute the escape velocity. And it basically said, assert that the PyTest result, and it's basically saying, well, it doesn't have to be exactly right, but it should be within, say, like, 0.001 is equal to this thing. And it said the assert fails. The number that we expected was 60202 compared to this obtain 59, which was that number. So I had to dig a bit to figure out what was going on here, because you don't know if the test is wrong or the code is wrong, right? In this case, both the code and the test can be correct. It depends on where you're standing on Jupiter. So NASA's Jupiter fact sheet claims an escape velocity of 59.5, right? This number, right? And that seems to be where GPT-4 got its test value. That's correct if you use this particular equatorial radius of 71,000 kilometers. But that's different than the volume, the average volume. So, because planets are not spheres, they're kind of squished. They use the mean radius rather than the equator radius. And so you get different numbers, each of which could be right, depending on whether you want to do it from the equator or from the average. So it just shows how, testing is tricky, right? And understanding what happens when the test fails can be really tricky. Okay, so let's talk about code review. So we talked a bit about code review yesterday. And many people don't have access to expertise that could help them with code review. And I think that GPT-4 seems to be pretty good at this. I'll show you some examples. This is, if you go to my clean coding demo on my GitHub, this is an example of some intentionally obfuscated Python code that I wrote. I basically wrote code that implemented a number of what are called anti-patterns. So in coding, a design pattern is a commonly used solution to a common problem. An anti-pattern is a commonly used but bad solution to a common problem. And so I basically wrote code that was like, the poster child for bad coding practices. And then I said, what are the Python anti-patterns that are present in the previous code? And it tells me, here's a number of things that you did badly, right? Wildcard imports, like from Panis import star. Single variable letter names. So going back to our, naming is important. Lack of white space, right? There's guidelines on how you're supposed to space things out. Using magic numbers. So putting a number directly in as opposed to putting a variable that says what that number means, right? Because if you go back later and you want to know what's 12, you're not going to know unless that was given to a named variable. That's what we call those magic numbers. So let's look and see, can it actually find errors in code, where like logical errors. So I gave it, I created a Python script that performs cross-validation, but it does it in a way that's incorrect. And again, that shows this leakage thing that I talked about, because it does feature selection outside of the cross-validation. It's exactly the thing that they did in that suicide paper that I talked about yesterday. I did this in one, you always, because you have to make sure that there's no like shared context between different GPT-4 sessions. So I did this in one session and then went to a whole new session and took that code and said, can you tell me what's wrong with this code? Okay, and it says there's nothing inherently wrong with the code you provided. It imports necessary libraries, loads a data set, selects features, blah, blah, blah. It's basically telling me what I'm doing, but it didn't catch the problem. So I said, there's a logical problem with how the analysis is being performed. Can you identify it? Sorry, I didn't identify it early. After re-examining it, I found a logical problem. Feature selections being done before the cross-validation. So it finds, with a little bit of prodding, it finds the problem that I had injected into the code, and it actually gives me corrected code. the corrected code that it gave me was actually correct. It moved the feature selection inside the cross-validation loop, which is where you want it to happen. So you have to push it a bit, but it does seem to be able to find code problems. The multimodal stuff is pretty cool. So I had an argument with one of my colleagues who didn't believe that GPT-4 could do this, so I went and did the experiment. So this is a figure from earlier, right? And I say, please generate Python code to recreate the attached figure, and I just paste a picture of the figure into the chat window. And the first time it kind of has, sometimes ChatGPT will do this thing where it tries to do something and it says, oh, I had an error, I have to redo it. And so here it basically generates, these data that are from a second order polynomial, or actually, sorry, from a ninth order polynomial, and then it fits the models. And that's not exactly what I was looking for, right? That's not the same figure. So I say the data should be generated from a linear model. And this time it pretty much gets it right. It's not exactly, because it didn't have enough noise in the linear model, so the ninth order isn't very wavy, but it's basically the same concept as what I had in my figure, even though it doesn't look exactly the same. And I don't know, I might have been able to tell it to go in and actually pick out the individual data points. I'm not sure that it can do that. That would be an interesting test. So I've talked about examples of using, the ChatGPT chat interface to do code generation. I think that the GPT-4 is pretty good at generating code de novo. I generally don't use the GPT-4, like the ChatGPT interface. I write code in using VS Code, Visual Studio Code, one of the free, I think it's increasingly recognized as the most powerful of the free development environments. It works for pretty much any language. And what's cool is that if you have an educational email, you can get a free Copilot account on GitHub. And then you can basically turn that on within VS Code, and it gives you, this is a picture of the chat window that can pop up over on the left. And it's basically it's like a version of GPT-4, but it only works for code. If you ask it, a question about American history, it'll say, I can only answer questions about code. But it's really good because it basically takes the code, like if you have a window of code you're working on, or you can select a piece of code, it'll take that code into your context. So if you ask it a question, here I say, generate a test for my code using PyTest. And it says, sure, here's a basic PyTest suite for your code. And it knows about the code that I have in the window that's open. So it took that into its context, and then now it's going to generate answers. So it generates answers that often you can just copy and paste straight into your code because it knows about your code and knows what variables you might be talking about. So I think this is for me, this has become a really powerful workflow. In addition to, what I showed before of basically realizing that if you put in comments, it will often just auto-complete based on the comment and do a really good job. Another thing that it's incredibly good at, so, when you're writing functions, it's nice to write in Python what's called a doc string, which is basically a little piece of text that goes just after the function definition that will come up if somebody does question mark name a function. And usually you want to say, like, what are all the variables that it's taking in? What is it putting out? What is it meant to do? In general, you don't need to write those anymore. ChatGPT or a Copilot will just write them for you. All you have to do is put in your 3 quotation marks and then start tab completing, and it'll generally just give you the doc string. Occasionally you have to change something, but it actually writes probably better doc strings than most of us would write because we find writing doc strings boring, and it doesn't get bored. So I think that that's a really powerful use of these tools. So I want to wrap by talking about some of the implications of the tools. And then I'm happy to answer questions if there's any kind of live demo stuff. We'll have time. So if there's any things you want to see, we can try to do that. But I think that these tools are going to definitely have a major. They already have. I mean, the fact that everybody 18 months ago, if I had asked that question in a room like this, very few people would have raised their hand. Right now, everybody's raising their hand. So I think that there are certainly arguments that they could improve science. I think that by doing things like, affording code review, refactoring, test generation, all these are things that in principle can make scientific code better, more reliable. Generation of simulated data, right? If you don't know how to write a simulation, you can probably get these tools to help you generate simulated data that you can then use to test your code. I think it's gonna, I've already seen in my lab that it's really helping novice coders get up to speed by, both by just helping them like learn the syntax and also by helping with debugging. When they see that there's a problem, giving the code to GPT-4 and say, hey, why is this crashing? So give it the error, give it the code. Why is this happening? I think that there's certainly concerns about the impact it's going to have because you can end up generating code that you don't understand and that you don't know how to properly test. You can imagine that that could lead to bad outcomes. Hopefully, that's just the first part of the learning curve, and most people will get to the point where they actually do understand what it's doing. But I think that there's a potential for people generating code that is doing things that they don't see. And as we saw earlier, you can't really test these systems to completely, at least to, you can't trust them to test themselves. You need a human in the loop to help with the testing. They're really helpful if you don't know what does a PyTest test look like. You can say, generate a PyTest test for this code or a set of PyTest tests, and it'll at least give you something that shows you what the tests should look like. And then if you have to tweak them a little bit to make them work, that's, at least you don't have to remember all the goofy syntax for PyTest tests. There are certainly reproducibility issues. These have gotten a little bit better, but for the most part, unless you take extra steps, tools like GPT-4 are going to give you results that are impossible to reproduce the next time. You can now set the random seed so that you can basically say, set this seed so that next time it will give you exactly the same answer. This is an example here where I say, output a random vegetable, and if I don't set the seed and I run that 100 times, 73% of the time I'll get broccoli, 13 carrots, 6 cabbage. If I set the seed, 100% of the time I get cucumber for that particular seed. If I gave it a different seed, I would 100% of the time get a different vegetable. You can also now get what are called system fingerprints at least for GPT-4, where it basically says, this is the version of the model you're using. So if you come back next week and the fingerprint has changed, you know that you're using a different model. And so you can't necessarily expect the results to turn out the same way that time. But these are things that one should think about. People who teach coding are like, really scared about what's going on. People who teach everything are, we're actually at our faculty retreat next month. We're having a whole discussion about how we should all respond to the prevalence of, AI-assisted everything, right? I had 2 students in my seminar that I taught in the spring who turned in things that clearly had been written with the help from GPT-4. Anytime something includes the word tapestry, that's like a huge signal to me that somebody used GPT-4 to write it. I don't know why it loves that word. So how do we test it? What does it even mean to know how to code anymore, right? Presumably knowing how to code means knowing how to solve problems correctly, right? It doesn't necessarily mean knowing the exact right Python syntax. And so we want people to be able to solve problems, and we presumably want them to use these tools to help them solve problems effectively. But the question is, what do they need to know in this new world that they didn't need to, or what don't they need to know now that they needed to know, 2 years ago? I think it's a really hard question. Also, how do we teach differently? For example, can we actually assess knowledge using these tools rather than just having people, complete problems like they would have in the old days 3 years ago? I think there's a lot of really interesting questions to be asked here that we don't have answers to. There's So I think, one of the things that we have to focus is actually teaching people how to use the tools effectively. And so this is an early 2023, so ages ago, example of using different types of prompting. This is an example of what was called chain of thought reasoning. So the idea is that, and this blog post from Martin Fowler showed an example of somebody doing this to try to build a web application. So in chain of thought prompting, instead of saying, write me code to do blah, you say, I want to generate, a program to do something. First break it down and tell me step by step how you're going to solve the problem. Don't write any code yet. Just tell me how you're going to solve the problem. Then say, okay, now write the code to solve the first part and the second part and the third part. And it turns out that can lead to much better outcomes than simply saying, I'd like you to help me solve the problem. Because the idea is that, what's happening in these systems is that they're using everything, they have all this knowledge that's in the model that's just fixed, right? And everything that they do in your chat session is based on like all the words that come before the prompt, right? And so the more knowledge you can get it to set up before it starts writing the code, the potentially better job it's going to be able to do writing the code. I'm hopeful that I mentioned test-driven development yesterday, and I'm hopeful that we can actually, this will kind of push people to start doing, it affords test-driven development because it makes it easier to at least get started writing the tests. And then you can basically get into this loop, I think, more easily. I'm hopeful. And I think certainly, using AI to generate code really drives you to need tests in a way that if you wrote the code, I mean, you should always have tests, but I think if you wrote the code from scratch, you have a better conceptual handle on what it's doing, as opposed to if AI wrote it for you. There's also, these new ways of thinking about doing this stuff. They're moving from just prompting to entire workflows that combine, things like, you give it a problem, you have it reflect on the problem, it writes some tests, tries to, solve the test, looks at which solutions, it does not just one solution, but multiple solutions, looks at which ones are better, and then kind of iterates on this. And so this particular example, this thing called AlphaCodium, that does this in an iterative fashion, seems to do a much better job at generating code than simply giving it a prompt and telling it to do that. So I think that there's a lot of work right now, again, super fast moving area, but trying to figure out what are the optimal ways to work with these systems to generate code. And they learned a number of interesting things from this AlphaCodium work. One is that if you want it to reason, giving it kind of bullet points rather than a bunch of text, it tends to do better at, because it helps it, I think, break things up into distinct concepts. LLMs do better if you have them generate modular code. So rather than saying generate one big function, you want to generate individual functions that each do a small thing like you're supposed to do when you generate functions. It's better to generate, rather than saying solve this problem and taking that solution, solve it a bunch of times and then compare the solutions and see which ones, whatever your particular thing is you're trying to optimize, find the one that optimizes that. And then, you want to make sure, so kind of like using the way that people often write tests on their own, you want to iteratively generate new tests, but then hold on to the tests that you've already validated and continue to test to make sure that you pass those, because if you don't, then you can pass the new tests but break on the old tests. Okay, so I don't think I need to convince anybody here that these tools are super exciting and super useful, and hopefully I've given you a flavor of what some of the limitations are, what some of the opportunities are, and things that you need to think about. And so we have a good bit of time for questions, and so I'm happy to open up the floor. Yeah.
Do you think there's any responsibility on OpenAI to be doing some of this work?
Some of what work?
Just like figuring out. Well, this question came to mind when we were talking about how ChatGPT is not good at I'm wondering if OpenAI has any insight into why that might be.
Yeah. Yeah. They actually have been doing work on that. So they've, in fact, one of the things that they've done is added, so they knew early on that it was really bad at math. So they've added, it's not exactly you think about it as like, having for particular domains where they know it's bad, they've added in kind of expert tools. So like now if you try to do math, it will use another tool. And actually, I think what it's doing is writing code to solve the math problem. It still isn't going to get all these things right because some of them are because of the, these models are trained to just predict the next token, where a token is usually a word or a part of a word or a number or something like that. And so I think the problem is that the structure of math just doesn't fit well with that. There's another thing that these models are really bad at. If you use, if you work with Copilot in VS Code, the thing that it is the worst at is figuring out brackets at the end of statements. So it'll often like give you the code and it'll stop before it gets to the end, especially if it's something that needs like a parenthesis and then a square bracket and another parenthesis. It almost always gets that wrong. Yeah, so there's something about the structure of those things that that are just really hard for these models to figure out. And it's an interesting question as to why that is. And I know they are trying to solve some of it. I don't know if they're, I mean, I think it's their responsibility to tell us, what it can and can't do well, right? I don't think it's necessarily their responsibility to make everything work, especially if it's not, within their business model. But it's certainly, I think it's on them to let us know when things work well and don't. And they've, like, if you go look at their tech report, there's a lot of stuff there about what it does right or wrong. Most of it is focused on kind of toxicity and that sort of stuff, which they've put a lot of thought into, less on math, but and other types of problems. But I think they are working on that. Say that again?
You said that document is on.
Yeah. Sorry, what was that?
I was just saying there's a couple online.
Okay, cool.
Thanks for your talk. If you were teaching, or maybe you even are, a data science heavy class this fall, I'm curious, what policies would you have around the use of AI assisted coding, and then also like to what extent, how would you incorporate that in the classroom?
That's a really hard question. Fortunately, I'm not. I had been teaching this statistics course for like 8 years, and I handed it off to someone else starting last year. But what's funny is like the last year that I taught it was actually right before GPT-4 came out. But GPT-3 was around, and codecs and stuff. So people were already asking about the use of these tools. And basically, what I said was, if you can use these tools to solve because the problem sets that I gave them were not ones that one could just go in and say like, hey, please solve the problem, because they had to like fill in blanks and parts of code and stuff like that. So there's already kind of a skeleton. So I basically said, hey, look, if you can solve the problem using an AI tool, please feel free, just tell me that you used the AI tool to help solve the problem. And a few of them told me they did. But that was before the tools had become as good. And we were also working in R, and the tools aren't as good in R. So I mean, it's a really hard question. I mean, I think I would certainly look for ways to incorporate the use of the tools in the class, because again, it depends on what exactly I'm trying to teach them. But I think it's, the question is like, are there ways to use these tools to help build the conceptual framework that, you're trying to build when you teach the class? Because ultimately, I don't really care if they know Python syntax, right? I want to know can they solve problems. And knowing Python syntax is a way to get to being able to solve problems. But if you understand how to solve the problem, and then you can get GPT-4 to write the syntax for you, I think I don't have a problem. I don't have, deep concerns about that, I think. But it's a really tough question right now. Yeah, let's take a couple more in the room and then we can go online. So yeah, back there.
Models, and I think they're going to be sometimes it just means people all begin to different. So is it like on us to try to hold it, or by asking those questions? Like I saw your format where you said that was the wrong equation. Is it like getting information that's Or is it just?
Oh, yeah. So let me repeat the question as I heard it, which is like, if like what happens when I say, oh, you got this wrong, is the like if you're using GPT-4, is OpenAI learning from that experience to make the model better? Is that basically your question? Or is there somewhere to report it? I don't think that I think that the understanding is if you're using these models, you kind of, come to it knowing that they're sometimes going to get it wrong, right? I don't know of any way to tell it that it got this thing wrong. Now is there like a thumbs up, thumbs down thing? So I think you might be able to do that. And I don't know how they use that. So, early on, GPT-4 initially didn't really learn from the interactions, right? The newer versions, my understanding is they are using some of the data from these interactions for kind of subsequent training, like, reinforcement learning type of training. But I don't know how, it's not, they don't tell people exactly what they're doing. So it's kind of hard to know. But I think the assumption is that in general, if you're using the tool, it's on you to like, to be aware that these models can do the wrong thing. And I don't think we can trust them to try to fix it. Yeah. Question, are there any AI-assisted coding tools that are safe for use with data that have private health information, personal health information? I would say that, if I wanted to work with those type of data, I would probably run an instance of one of the open source models on my own computer, because then that that information is not going to leak out and go back, right? Those models in general aren't as good as GPT-4, though they're getting much better. And so that's probably what I would not, unless you're paying a company that guarantees. There are companies that will serve you an AI system that they say is safe for PHI. If you want to do it on your own, I think running an open source model on your own system that's secure would be the way to go. All right, let's go online. Angelina.
Yes, thank you very much for your talk. That was really, really interesting. Something that I sometimes wonder about is when I use ChatGPT-4, I oftentimes use it to do things like scaling my data or log transforming it. And of course, I would never check the values after because it's not like I can readily check this. So I'm wondering, for basic math operations like this, do you think that we should be questioning the outputs and further checking if the data that's up is actually correct?
Yeah, it's a good question. I generally would not trust it. I would not give it data and take data back from it. What I would do is ask it to write code to do the thing that I want to do with the data. And then I can at least, look at the code and know that it has done the right thing. And I can test the code if I want to. Yeah, I would be worried about trusting it even though it generally will do a good job of reproducing the numbers as it should, because these systems have, probabilistic noise, you can't trust that it's always going to do it correctly. So you either have to test the data, or take the code and then have it, somehow check the code to make sure that it's doing the right thing.
Right. Thank you very much.
Yep. Let's see, Melissa.
Hi. So my question is kind of a bounce off of someone who just asked the question in person, but with the language models and them kind of using input data, and I think ChatGPT has opened up more novice coders or people who've never coded before, and a lot of incorrect codes. So do you think that coding is going to get worse because it has all these inputs of incorrect codes, or do we think that the models can figure out what's correct and what's not?
It's a really interesting question. There was actually just a paper in Nature, I think this week, about this phenomenon of what happens when you train language models using text generated from language models. It's called the Ouroboros phenomenon. It's like when a snake eats its tail. And they show, at least in that paper, that it basically leads to this failure of the models when they start basically when their diet includes too much of their own kind of self-generated code. And I think that could certainly happen as more and more code on GitHub is code that was generated by, these tools. And it becomes worse. And, certainly like I bet if you go look at hurdle regression models, you're going to see all of them having this, this incorrect way of specifying the model. And that's just going to, any case where there's like a small error by a human coder can get amplified. And, suddenly that becomes the only way that the models ever solve it, because that's all they see in their training data. So I think it's a significant concern.
Thanks.
And one thing that, people in the language model world, I think, are coming to realize that the quality of the training data. So, people have focused so much on the scale of the training data, not worrying about its quality, but I think people are coming to realize that the quality of the training data really matters a lot. And so hopefully that, you just need to have a way to know what's the quality. Yeah.
Thanks.
Given a little bit based on a lot of these questions have been asked, I was also thinking considering the propensity of the errors that can be generated from these large language models, and also I guess the newness of how other people you just kind of almost blindly implementing this. Do you think that there's an ethical obligation? You're right, there's an ethical obligation to report the use of ChatGPT or the large language models in a published paper, hey, we use for instance, ChatGPT to determine this sort of code, and if so, do you think that it would be obligatory almost to report hey, this is exactly how we ask ChatGPT for this output? Do you think if that's not already an obligation, do you think that could be something?
Yeah. So the question is what obligation do we have as researchers to disclose the use of these tools for research code? Right now, I think that, so I think pretty much all journals have now instituted requirements to disclose the use of these tools in writing of the paper. I haven't seen them require disclosure of their use in the research process. I think that's probably coming. I think it would be really difficult to get the kind of granular description that you're asking for, in particular, because when I code in Copilot, it's, I'm writing code, it's completing stuff for me. It's really impossible to know what parts I wrote and what parts the AI wrote. So I think that, we generally will say, in our most recent paper, we used it to help generate code for some figures, and I disclosed, ChatGPT wasn't used in the writing, but it was used to help generate code for figures. And we increasingly use it, there's all sorts of annoying stuff that you have to do. I was trying to take some stuff from a PDF that was a table with a list of contrast numbers and contrast names, and I only wanted the odd numbered ones, and I just copied the whole thing and put it into ChatGPT and said, please extract the odd numbered things and turn them into a Python dictionary. And it's boom, it does it. So there's all this kind of stuff that's not really writing analysis code, but it's use in the research process, or generating stimuli. One of my students used it to generate a bunch of anagrams, right? There's all sorts of things like that I think people are starting to use it for, and we probably need to be disclosing all of those. But the question of how granular it needs to be is a good one that I don't think we have a handle on. Dr. Van Horn?
The outcomes of your faculty retreat coming up at some point, about the use of ChatGPT and artificial intelligence methods in terms of plagiarism. And there's several efforts that are attempting to use AI to detect the use of AI. I'm curious about your impressions of their success or failure.
Yeah. So the question is, what do we know about the tools that people are developing to try to assess the use of AI particularly in writing, plagiarism detection, or detection of ChatGPT generated text. So in the case where I had these students who, wrote something that was, well, one of them, it wasn't clear to me that it had been written by, I didn't get a sense when I read it that it had been written by ChatGPT, but my TA read it and they're like, oh, this is totally ChatGPT. And the other one that I read, it was clear within a paragraph, once I saw Tapestry, that that this had been written by ChatGPT. So I reached out. I don't have any feedback about what happens with the second one, because that wasn't detected until like after the grades have been submitted. But the first one, I reached out to the student and said, hey, it looks like this was written using an AI tool. And they wrote back and said, well, I actually used ChatGPT to help improve my initial draft. And they sent me the initial draft that was the thing they had given to ChatGPT. And it was like, you could see the same stuff was there. It was just like much more flowery after ChatGPT got to it. But I put both of those into a couple of these different Detect GPT, and there's one other, and they were kind of all over the place. Like one of them for both of them said, yeah, 100% use of AI. The other one for both of them said, no, it didn't. So it just, depends on, I think that's a losing battle to try to develop tools to assess the use of AI, because the better AI gets, the harder it's going to get. And students can also, presumably, they're going to learn what are the things you need to do. They can also put it in themselves, right? And then see, what do I need to change in order to get it to not detect it as AI generated? So I think it's a losing battle. I think we have to, I think this is it's a good disruption in the sense that I think a lot of the ways that we have assessed knowledge in the past aren't particularly effective. They're kind of lazy, if you will. And I think that this is going to force us to rethink that, and hopefully, moving towards things like project-based learning and stuff like that, where, you're not just looking at a piece of text that somebody generated, but you're looking at a process, or, for smaller classes, actually going back to like oral exams or something like that. That could be interesting. Yeah.
Do you foresee this becoming a problem over time, and we're going to have multiple GPTs that are going to be different?
So the question is about kind of like private language models, where an organization takes a model and trains it on kind of internal data, and then it isn't available to the rest of the world. I guess it depends on what it's being used for, right? Is there a particular use case that you have in mind that is concerning?
We're creating. So like there is a lot of things you design, let's say like my research is given. And then they're used internally, but like it's only on the research that's created by that institution.
And what are they being used for,
The place, but a lot of people are using it for the system code or.
Right. Yeah.
There are issues where like you're going to have many universities.
Right. Interesting. Yeah. I mean, the immediate concern that comes to mind is like, if you're using a system that was trained only on like research that came out of your university, then what are you going to be citing? Only the research that comes out of university. And there already are a lot of, I think there's a tendency amongst researchers to only cite their own work or the work around them. And so that just kind of like intensifies that. My guess would be that for the most part, I mean, because these models, in order to perform well, require so much data, my guess is that these models just aren't going to be very good. That like most people are not, unless they're like really a specific use case that can only be accomplished using that internal model. I would guess that most people, unless they have that specific use case, they're just going to go use GPT 4.0, because it's going to be so much, there's no way that a university's IT people can compete with OpenAI, right? But I can imagine that there might be use cases where, like, for example, if there's student information or something where that they want to, be able to quickly access, because these models turn out to be really good at like just memorizing things, right? So if you want to use it as like a search tool for the university's data, then I could see that being a useful thing. And then it's not clear that it's that different from other databases that the university has that are only internal. But I would worry about it for research purposes, just because I don't think it's going to be very good. Another?
So I was learning coding before GPT existed, and I forgot how to get this stuff in workflow, in all honesty. So
Yeah.
Do you really feel like the chat GPT coding for people is actually right? The big code on the internet, but
So the question is, how is using ChatGPT to write code any different than copying and pasting from Stack Overflow, which is what all of us did before these tools became available? I think one thing is that when you copy and paste from Stack Overflow, you have to do some thinking, right? Because in general, the code isn't just going to run. You have to like tweak it in order to like fit with your, it depends on what it is, but often to fit with your use case, you have to kind of do some tweaking, and it requires a level of thinking about what the code is doing that, I think isn't necessarily required if ChatGPT can write some code that you can just kind of, plug and play. That said, I don't think it's that qualitatively different. When you're learning to code, you need examples to work from, right? And you can get examples from Stack Overflow, you can get examples from GPT-4. My guess is that, there's a lot of variance on Stack Overflow posts, right? And so in some sense, and obviously GPT-4 is trained on Stack Overflow along with a bunch of other things. So, it's almost like it's a slightly better curated version of Stack Overflow. But it's hard to know. I haven't seen analyses that have kind of looked at this. It would be interesting to know. Yeah. Yeah.
Is when I have code that wasn't working, I just created by myself or by ChatGPT, right? To ask it, thanks, is there a more efficient way of coding this? And then it would introduce me to a whole new package, or introduce me to the concept of class and Python, and using Python. I was like, oh, that's useful. And I would have never Googled for that because I didn't know it existed. So maybe I would come across it at some point in second. So, but like if there's something that you don't know about at all, it'll come across much faster.
Yeah. I'm going to just repeat that point because I think it's a good one for the people online, which is that when, one particularly useful thing to do is if you have code that you've generated or that was generated by, some tool, or you copy and paste it from Stack Overflow or whatever, actually asking the AI tools to rewrite it in a way that's cleaner or more efficient, and then looking at how it actually accomplishes the problem to see if it can, kind of show you a different way to do it, because there almost always are multiple ways to solve a problem. And part of learning how to code is about learning, not just how to solve it, but which ways of solving it are best in which situations. And so I agree that that's a good way to kind of like help you learn that and discover new ways to do things.
Okay, we're past time here, so let's thank Russ again